Hello mathematicians, this is the video for home connections 81 and 82. Number 1, what is the best estimate of the height of the ceiling? I often think of the height of a basketball hoop, which I know is 10 feet. 10 meters, think of 10 meter sticks. I would say the height of our classroom is probably only about 3 meter sticks, so 10 feet is definitely the best estimate. The length of a mouse is best measured in what unit? So you want to choose the biggest unit as long as that unit is not bigger than the object you're measuring. So feet, too big, that's longer than a mouse. Ounces is a measure of weight. Yards is much longer than a mouse, so centimeters would be the appropriate choice. Number 3, what is the best estimate of the distance across your classroom? Our classroom is about 10 meter sticks, way too long. A yard is a little bit less than a meter, way too long. 30 kilometers, a kilometer is a bit less than a mile, but still far too long. And 30 of them, again, way too big. 30 feet would be correct. Again, I often think of basketball hoops. 3 basketball hoops laying on the floor, that would reach across our classroom. Number 4, which of these units would best measure the length of a ladybug? You want to choose the biggest unit as long as it's not bigger than the object you're measuring. Bigger than the object we're measuring, bigger than the object we're measuring. Grams is a unit of weight, so millimeters would be appropriate. Number 5, which of these units would best measure the length of a pair of scissors? The biggest unit as long as it's not bigger than what you're measuring. Grams is a unit of weight. Ounces is a unit of weight. So between feet and centimeters, scissors are not quite a foot, so I think centimeters would be appropriate. On to page 82. Number 6, the distance across the state in which you live. So the distance across Ohio, gallons is how much liquid something is, capacity. Ounces is weight. Miles would be appropriate. So again, the biggest unit of length, as long as it's not bigger than the object we're measuring. 7 and 8, I'm not a big fan of how they set up 7 and 8 horizontally. I think it would be a bit easier to understand if they were written vertically. Number 7 says, Kim was using a give and take strategy. When you're adding, you can give to one number to make it a bit easier as long as you take the same amount from the other number. So we're going to look from the first number to the first number, and I can tell that they are adding 1. If you add 1 to one number, you better subtract 1 from the other to get 586. So the give and take strategy in this did make our addition problem easier. It is much easier to do 1,000 plus 586 than it is to do 999 plus 587. This one is definitely easier using that give and take strategy. And 1,000 plus 586 is 1,586. Number 8, Kevin was using the constant difference strategy. If you are subtracting and you want to make a number a little easier, then you also have to do the exact same thing to the other number. So the difference between them, which is what subtraction is, stays constant. So when you're subtracting, it's different than when you're adding. I can tell that the second number, they wanted to change it to something much easier. 800 is way easier. They added 1 to get from 799 to 800. In order to keep the difference between the two numbers constant and consistent, I actually also need to add 1 to the first number. 1,256 would be 1,257. So we gave and we gave, and it did make it easier. This subtraction problem is much easier than this subtraction problem, although I still don't think I can do it in my head. I think for this one I would still show it off to the side, but it is easier because of all those zeros in the number 800. I can do it without too much regrouping. 457. Number 9, this challenge problem is all about multiples. It says Owen had 3 different kinds of stickers. He put a bird sticker on every 30th page, a sports sticker on every 50th page, and a robot sticker on every 60th page. And they're wondering, if this book went up to the page 600, would any of those pages have all 3 stickers on them? So I am first going to write down the multiples of 30. So you could think 30 times 1, 30 times 2, 30 times 3. You could think skip counting. You could also just imagine the number 3 and do the multiples of 3 and just tack a 0 onto the end. So I'm going to write down the multiples of 30 all the way up to 600. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. We're halfway there. We're going up to 600. 330, 360, 390, 420, 450, 480, 510, 540, 570, 600. So those are the multiples of 30. Then I'm going to do the multiples of 50 up to 600, and that's going to be much easier. Multiples of 50. You could also think multiples of 5 and just tack a 0 onto it. 50, 100, 150, 200, 250, 300. We're already halfway there. I don't need as many of these multiples because 50 is bigger than 30. 350, 400, 450, 500, 550, 600. And lastly, multiples of 60 all the way up to 600. Multiples of 60 would be every other multiple of 30, just like multiples of 6 are every other multiple of 3. So I'm really just going to write down this, and this, and this, and this, and you get the picture. You could also think just multiples of 6 and tack a 0 on. So the multiples of 60 would be 60, 120, 180, 240, 300, 360, 420, 480, 540, and 600. And remember, the question is, will any of the pages have all 3 stickers? Which means if I see a number on all 3 lists, I can circle it. Okay, I see there's a lot of commonalities between 30 and 60. I feel like focusing on that 50 is important. I don't see 150 on everything. I don't see 180. Let's see, 300 I see on all of the lists. 450 is not on all the lists, and I think just 600. There they are. So 300 and 600 are on all 3 lists. So those would have all 3 stickers. All right, kiddos, here are the answers to 81 and 82. All right, I'll see you in class.